So, according to this table, anthropologists can predict how tall a woman is based on her humerus. Now, anthropologists, we're talking about people that study like old skeletal remains. And so sometimes when they find skeletal remains, well, doctors too, but I mean, this is where it's the most useful. They may not find all the parts, is the nicest way to put it. So if they find a humerus, and that's the bone from the elbow to the shoulder, if they find that, they can guess about how tall a woman is based on this data. But right now they just have data. So how do they make a prediction as to how tall a woman is? How would they do that? What do you guys think? What could they do with this data to figure out a way to make predictions? What have we been doing? Graphing the data, and then what? And making an equation that fits the data. So let's try that. Turn your calculators on. Go to stat. This is the last one. I know you guys, first of all, I appreciate you guys paying attention, but don't lose interest. This is the hard one. This is the last one. Okay? Go to edit. We want to clear it out, not delete. So go to L1, hit clear, then hit enter. Go to L2, hit clear, then hit enter. Okay? So now let's go to the left. Let's plug it in now. Among those two things, what do you think is the independent variable? The easiest way to answer that question is, what is the dependent variable? Yes.
The humerus length.
Is independent? Well, I asked two questions. What is the humerus length?
The independent length.
Very good. So the humerus is independent because we're saying that the height of the woman depends on how long her humerus is. Does that make sense? So sometimes when you got to identify the independent variable, the easiest thing to do is figure out which one is the dependent and the other one is the independent. But that was correct. So for our x value, L1, we're going to enter in all these items. So I'll just enter those into my calculator, and you can see them on my screen. Or just look on your book in page 21. Let me move my book a little closer so I can see it. So it's 31, yeah? No, 35. Off to a bad start. 35, 27, 30, 33, 25, 39, 27, and 31. I think that's right. I don't know. We'll find out in a second. Then I have 167, 146, 154. I always mess up when there's big numbers. 165, 140, 180, 149, and 155, I believe. So now I'm going to double check everything. 35, 167, yes. 27, 146, yes. 30, 154, yes. 33, 165, yes. 20, 25 and 140, yes. 30 and 180, yes. Or 39, I'm sorry. 39 and 180, yes. 27 and 149 and 31 and 155. Okay? Did you guys get all that entered in? Need to leave it up there for a second? Okay. So now what do I do? Let's graph. How do I get to graph this? Huh? We're going to hit, well, zoom, yeah, eventually. But remember, we got to switch this. So hit second, y equals for our stats plot. And we're going to go into plot 1. Remember, I want to change this back to scatter plot. So let's change that back to the scatter plot. So make sure when it comes to type, the first one is scatter plot. Then hit enter, 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 L1, L2. Now hit zoom. What option do I choose? 9. Zoom stat. There we go. Does that look like a straight line? Kind of. So if I come up with what type of equation? What's the name of an equation that's a straight line? Linear equation. How do I come up with a linear equation? I make one up. What's the fancy math word that we learned? Linear regression. Very good. So what we're going to do is we're going to hit the stat button. See where it says calculate? Hit the right cursor till it gets to calculate. There are two linear regressions. We're going to do the first. They're the same thing. They just reverse the order. You're saying, Mr. Adams, why? Well, in Europe, they do it backwards. Or they would say that we do it backwards. So here in the U.S., we do AX plus B. Some countries overseas do B plus AX or A plus BX. It really depends. Anyways, we're going to choose option number 4, right? Our X list, our X values are listed in L1 because we said the humerus lengths were the independent variable. Yes, you have a question? Okay. So I got you. So when you go here, you had L3 here? Okay, watch this. Look at the buttons 1, 2, and 3. What do you notice in blue right above those? So what I could do, so basically somebody accidentally deleted L2 on his calculator, and then they put in L3 because they put the information in L3. If you ever need to change this, you could just do second and then L3, or I'm going to switch it back to L2. Does that make sense? Now I'm going to go back to Zoom plot, or actually we're calculating, right? This is where we left off. So I'm going to choose option number 4, linear regression. Now, the calculator will tell me the linear regression, but I'm lazy. I don't want to copy that number and put it in y equals to graph the graph. So, does anybody remember how we do this part? Press the vars button, which actually stands for variables. I don't know why we pronounce it vars, but that's how it's spelled. What variable do we want to store this in? Y1, so we go to y vars. Is it a function? Yes. In high school, you're always going to choose this first option. You could do other types of other types of equations, but we're always doing functions. Y1 is the one we want. Hit enter. Wha-bam with the bacon sizzle. That's the equation, or the A and the B for the equation. If we hit graph now, get on my level. What if I want to change the color of that line? What do I do? I'm going to go to y equals. I'm going to go over here. I'm going to hit enter. I can pick any color I want. I feel like green today. Boom. Hit graph again. All right. So we just have to write down the equation and then figure out what the domain is. Well, in this particular case, I'm going to abbreviate it. All right. So if I hit trace and go up here, I get all this garbly stuff. If I round that, so let's write down the equation. I'm going to round that. So I'm going to say that the height as a function of the humerus, and we'll say the length of the humerus, right? So we'll call this L, and we'll call this height. So the height as a function of L is about 2.75 L plus 71.97. That's about what it was, right? So where is that coming from? If you round all this up or down, right? I think you round down in both cases. Now, the other thing they want to know is the domain. So to find the domain, we find the lowest x value. What's the lowest x value? 25 on that. What's the highest x value? 39. So then for this, my domain is referring to my L values, and it is 25 and 39. So now here's the beauty of this. Let's say that we discover a woman whose humerus is 43 centimeters. Can I make a prediction about how tall she is? Yeah. I could say that her height is equal to 43, and then I plug it into the equation 2.75 times 43 plus 71.97. If I plug that in my calculator, I go to trace and I plug in 43. Oh, it's outside of the window, so I'm just going to look at the table. I'm going to put in the table of values. So if I go second, here's another way you can find that information. If I just scroll down here to x equals 43, it'll tell me the number. Did you guys know this? You're learning today. So when L equals 43, my function equals 190.39. 190. Okay.